Hello, everyone. Welcome to She Code Nairobi, and welcome to our Tensorflow session. So this evening we will have Teams who will take us through getting started with Tensorflow. I will introduce Teams, Teams will introduce himself, and then he will take us through the session. Right, Teams?
Yeah, sure.
Okay. But Teams is not his real name. He'll tell you his real name.
Yeah, so my community and tech name is Team Zoen, but officially, according to the Kenyan database system, I'm identified as a Kalenjin, Kipkosgei Timothy, and Owen is just a family name. So when you go to social media, you'll find me as Team Zoen. So Teams, who's Teams? Teams anyway is an Android, old school Android developer. So still developing Android apps with Java and doesn't want to move to Kotlin or Flutter. Yeah, but I'm really into machine learning, but especially the part of using TensorFlow. Shortly, we'll just get to understand what TensorFlow is, and are we going to write our first program? And thank you so much for the shouts by She Code Africa Nairobi, and we're going to chat. Wow! So we're going to take the shortest time possible, and actually at most 30 minutes, because TensorFlow, it's not complex, but mostly TensorFlow is a library which requires a lot of time to learn. But if you're a really dedicated team, then or a person, you're going to actually get started very easy. So I'm going to share my screen so that we can get started. So you can tweet me up at Teams Owen. So I'm more active on Twitter than any other platform. So I'm just going to share my screen. So, but before I share my screen, so let me just let me play a video here.
Sound analysis is used in so many fields, such as identification of music and the identification of the type of animal based on the sounds that they produce. Sound is critical to what we're doing because physiological sounds are very important in medicine, but the traditional stethoscope hasn't changed for close to 200 years. The doctor is limited by the human ear and they cannot hear specific frequencies. This method is very inaccurate and causes a lot of misdiagnosis. Our mission is to use machine learning and TensorFlow to revolutionize the diagnosis and treatment of respiratory diseases in low-resource areas such as sub-Saharan Africa. The Tambua app is a powerful screening tool that helps doctors make decisions quickly. The core technology is trying to mimic the human auditory system. Once the patient walks in, the doctor collects the lung sounds with symptoms, risk factors, and vitals of the patient, and then the Tambua app combines all that information and gives the doctor a probability of the patient having a specific respiratory disease.
Kuna any abnormal breath sounds?
Eric introduced TensorFlow to us because he felt that we can use TensorFlow to go through all the stages of development to deployment of our model.
Our model uses spectrograms. We take sound data from the digital stethoscope and convert it into a visual problem that the computer can best identify. We have worked with a number of clinics and pathologists, and we are able to collect data from 621 patients, and then we use that data now to build our machine learning model.
Once we had trained and evaluated our machine learning model, we deployed it on our Tambua app. TensorFlow Lite helps us to perform an inference on a mobile device without the need of a connection. So doctors can use the Tambua app offline without connecting to the cloud. There are 216 healthcare facilities that are using the Tambua app and the Tambua devices. These clinics are spread out and some are very rural clinics.
It's really a nice project. I can elicit a crack call plus the vital sounds. Then when I add the clinical history and the other physical examination, there's no need for me to take this patient for an X-ray. Misdiagnosis, which is one of the problems leading to deaths in Kenya, is really creating awareness. Tambo is helping me. It shows me even the things that I would have missed in case I had the traditional way of doing it.
Over 2.5 million people die each year because of pneumonia, asthma, COPD, and pulmonary tuberculosis. I believe that we can use machine learning in treatment and management of these respiratory diseases.
Yeah. Okay, it's cool. So that was really that was just a video by Tambo Health in Kenya. So these are Tensorflow company that mostly focuses a lot on using Tensorflow. So they're using Tensorflow especially in getting to some input from the user and getting to analyze. So we get to understand totally what Tensorflow and the role it plays on deep learning. So I'm going to share my slides so we can just get to finish this one. Cool. So we're going to directly get started. So I had earlier said, my name is Tim, so don't worry about my hair. So I must look different from my former style. So the first thing I want us to do is so these are already the video that I had already played about. So let me just stop. So the first thing we're going to do is we're going to understand exactly what TensorFlow is, then the role of TensorFlow when it comes to deep learning. Then we are also going to understand about the roles of tensors and graphs and nodes, because if you look at TensorFlow, so TensorFlow is actually like everything happens in graphs. So we'll go back a little bit to the video. So I want to play this again. So and then I'll just pause it at some point. Let me pause it at this point. Okay, cool. So there is a place it involves when you look at when the video is already starting, there's always the graphs and everything. So everything is involved with plotting in TensorFlow. So the next thing we're going to do is we're going to understand about the elements, TensorFlow elements. So that would be including the way graphs flows and the way execution happens in TensorFlow. Then we're going to look at some of the real-world application. So we've looked at the way Tambo Health is optimizing and the way they are using TensorFlow in their products. The way they're actually making it easier for the old school stethoscope by using machine learning in Android. Because somebody would ask, like, how are you going to train maybe like a machine learning model in mobile devices or an embedded system or the iOS the edge, despite the fact that it actually takes a lot of memory and it also takes a lot of time. So we're going to directly jump into this animal called TensorFlow. So if you look at TensorFlow, this was just a library developed by Google Brain team for to make sure that machine learning was actually like made easier when it comes to doing research. So the thing was to reduce a lot of mathematical computations. So because if you look at it, somebody would ask me like, why would I have to learn machine learning, or why would do I really need that knowledge of mathematics when for me to start learning machine learning? So this is what TensorFlow is doing, and also some like Keras and other libraries. So they are trying to simplify a lot of computation. So a lot of mathematics and old stuff. So you only need to use these libraries. You just have to import and get things up and running. So the next thing is what actually TensorFlow is from the term tensor. So tensor is just a multidimensional array. So we have different tensors. So we're going to look at what these different tensors are. So we talked about it being a graph. So everything in TensorFlow is a graph. So we'll come to understand what a tensor board is. So you can visualize like the way I can sum up something. So I can add two numbers and then I get to visualize the addition in actually a graph. So then you can run very fast computations. So like quantum computing. Actually, the future is with quantum computing. So a lot of computation that would have taken years are now being executed within days or within minutes or hours with the quantum computing. And what powers quantum computing now is machine learning. So what this happens is I have some is a diagram of demonstration here. What this happens, we have edges and tensors. So these circles here are called the tensor edges. So we have the nodes. So we have different nodes, and then we have the way they sum up. It's just like declaring a variable in maybe like Java or any other language. Then you now maybe like say int a equal to b, and then you sum up. So this is what is happening. So you declare your variables, then you have to align the way your graphs flow. So you will now be having computations in between this. So once you are out of the declaration, but the good thing with TensorFlow 2.0 is that you don't have to declare your variables, and because it was a lot of boilerplate codes in TensorFlow. So this what this happens is it uses nodes and operations. So and the thing here is we have sessions. So something like the way we'll have our environment. So the way we'll have maybe like console in actually, like, let's say you are running a Python program, then you will have to print them to console, then you will have to say print, like the print function itself. So the sessions, so you cannot do anything without the session. So you'll have to instantiate the session so that you can see the output. Then you can pass the output to different devices. And somebody would ask me most probably, why will I learn and where would I use TensorFlow? So when it comes to machine learning, the way you're going to design and train your models. So in TensorFlow, when you are going to perform your computations, you're going to run them on either a GPU or a CPU. And then we have the TPUs. So the thing about this is that when you want to run them, there's a difference between them. So from your judging point, there's GPU, of course, and the CPUs. The GPU will always be faster than the CPU because it's also, the first thing is also in the cloud. Then and unlikely. So if you want to run TensorFlow on your machine, so that will actually, remember I said that TensorFlow takes a lot of time. It requires machine resources, and it actually heats up power. So that's why Google team came up with the GPUs. So you can actually use GPUs, and there are free tiles GPUs, although you pay, but you can use GPUs to execute. So here comes the difference between now the CPU and the GPU. So the ones with the blue is the GPU. So you can see that it takes the shortest time with the minimal, minimal resources, especially if you are giving the training data set in terms of epochs. So that means you're going to spend little time, and you're going to actually get your output very fast. So the thing about this is, recently, or not recently, but there was introduction of TensorFlow.js. So you can perform inferences on the web. So you can just like perform different inferences and continue like working on different machine learning models on the web. And for Android, there is a TensorFlow Lite. So you can perform inferences on IoT devices, embedded systems, and mobile devices. So without consuming time, resources, and everything. And then there's the APIs. So we have the, so actually TensorFlow APIs mostly are built in C++. But now we have Python, and you can build your model in Python, in Java, and then you can actually, we have something called saving in state. So once you save them in state, then you can transition to different production models. So you get to understand what actually that what the way you're going to transition in different models. So again, there's one thing here. So we are going to see what model subclassing is, and which actually like helps to reduce the topology complexity in TensorFlow. So a must know terms. So just like the way we have variables, the way we have functions, we have data types, the way we have rules in other programming languages, TensorFlow is not an exception actually. So there's something called placeholders. Although this is actually almost void in TensorFlow 2.0, but I'm going to do my examples and code sessions on TensorFlow 1.0 so that we can get to really have that basics before we transition to TensorFlow 2.0. So placeholders, they are just variables to be used in place of inputs. So remember, we add this place. So we have your inputs. This is where you're going to receive your inputs. And then as you continue compiling your sessions, so that's how the transition is happening. So then the variables are just the model variables to be optimized. So once I have, so there's difference between a placeholder. So at this point, we have placeholders. Then once we are in the graphs flowing, that is where now we have our variables. So these are actually the actually what we call now. Let's say these are the models, the inputs that have already undergone transition. So while it's undergoing transition, then it's now in that state of being variables to be outputted at the final state. Then we have the model. So a model, because in machine learning, you would ask somebody, what are you doing? Then you will get actually to hear this term more often. What is a model? So a model in actually layman's language is a function. So this is just a function. So just the function is just a whole house of code trying to do something in minimized lines. So it actually allows you to just call, like the way we have different math functions like the flow or the round, just the random. So in TensorFlow, we have different methods. We have different actually, and these methods actually come in terms of different functions. So when it comes to functions, we have gradient descent functions. Of course, we have so many other TensorFlow functions. So, but the gradient descent function is actually the most used. We'll come to understand other different forms of activation functions in TensorFlow. Then we have laws. So actually, how would you know that a model is performing? So when it comes to TensorFlow, and we are going to understand how do you see the progress of your model in terms of performance. So we're going to calculate loss. So we have something called gradient descent loss. So we're going to check out that works. Then optimization. So you've heard of people talking about optimizing your model. So how are you going to optimize it? So that's what we're going to do next. So under sessions, we've talked about them earlier before. So it's going to book space in your computer. So if you're using your CPU, then it's going to book space in your CPU. Then if you're using GPU, then it's going to book space in your GPU. Like I want you to store these values, and this is where I'm going to carry out my functions. Yeah, so this is where now we come to understand about the role of TensorFlow in deep learning. So if you've heard of deep learning, then of course you've heard of keras. So one thing about keras is it allows you to actually perform a lot of computations in terms of networked layers. So and when it comes to keras and the TensorFlow, when it comes to deep learning, so everything is in terms of neurons, just like the way your brain works. The different neurons actually all connected. That's why if you look at these places, then we have the input. Then we have different resulting networks. So the input becomes the input to the next layer, and the next layer now becomes the input to the next layer. So the next thing is it's actually like chaining it. So the main point of chaining is determining the best rules, just like we have supervised and unsupervised. So what neural networks does is it's almost a kind of an unsupervised learning, where now it figures out actually the number of layers will determine the performance. So the more the layers and the more the actually input and output, then that means our model will now have a better training. So and during this hidden state, that's the networked layers. This is where now we perform something called feature extraction, and now the algorithm being computed is being formed. So assuming that we have input 1, 2, 3, and then these are data that are labeled. So then output Y1 and Y2 is the expectation, so the predictions. So this is where now the activation function comes in. So with the inputs and the outputs, so in between, we now have feature extraction. So this is now like trying to determine the pattern. So maybe like we've labeled different types of dogs, like German Shepherd, and we have our Kenyan one. I don't know if they have names, but so let's say we now bring in a new dog. So how are the rules going to be formed? So the rules are going to be formed inside the nodes and the neural network layers. So and tensors, so something called tensors. So tensors like TensorFlow. So we have the tensors and the flow. So we've talked about tensors. So the flow is just the graph execution. So like from which step will these nodes be flowing to, so that we can form a computed output. So that's just in terms of the edges. But for tensors, it's actually like, in simple language, is a generalization of matrix and vectors, or in simpler words, is a number with specified shapes. So from this point, so we have something here. So the 0D, so that's a zero-dimensional tensor. So we call it scalar. Then we have a one-dimensional tensor, which is called a vector. Then matrix. Then we now move in accordance to the number. That's the cuboid, which is a 3D tensor. Then all the way to the end tensor. So actually, this is important because when you are building your model and giving in input, then you're going to specify the shape of your model. So you're going to understand that a little more when it comes to practical sessions. Yeah, so we're going to perform a few lines here of code. Yeah, so okay, cool. Now let's see how we're going to build our first program in TensorFlow. So we're going to say that once it comes to execution, so we're going to, the first thing, of course, is just like a Python, Java. So you're going to first install that one thing. So, and that's TensorFlow. So when it comes to installation of TensorFlow, so either you're using a PyCharm, you're using Anaconda, Jupyter Notebook, or any other online notebook. So the first thing you're going to do is you're going to import TensorFlow. And then this is actually like the way you are doing it now in code. So the zero-dimensional tensor, so just go, after you've imported as TF, so once you call TF, the compiler will know that we are now referring to TensorFlow. So you're going to say TensorFlow.once. So then you're going to pass in 1 for the zero-dimensional tensor, 2, then we can have a two-dimensional tensor, which is a 2x2. Then we can have a 3x3 dimensional tensor, so which we are going to increase the number. So I just forgot in the curl brackets here, the brackets here. Then if you want to print this, then it's actually very simple. So you just do you're just going to call a numpy. So numpy is actually like the simplest way of performing math in machine learning. And then we've talked about these rank. So we've talked about the one by one. Then that's a scalar. Then we talked about we have this different one. So that's the row vector. Then we have a vector column. So we can have actually a two-dimensional tensor, which is in fact 3x1 or 1x3. It doesn't actually like matter a lot. So especially if you have specific features. So like you'll train your ant to be up this way. Then the next time you want to predict it on this side. So that's going actually, that's why you have to give all angle points. So you're going to give a 1x3 or a 3x1. And if you have a cuboid, then you're going to give all the sided features. Now, the next thing we're going to see is let's perform a simple addition in TensorFlow. And one thing about TensorFlow is like we have different variables. So we have constants. So like the way you're coding in Android or any other, I believe so, any other environment. So you'll have your actually like your constant values. So in TensorFlow, once you're using the constant, so that means your value will not change during your execution or during your training. So the next thing is once you have done that, so with TensorFlow 2.1, 1.0, you have to declare this. But in TensorFlow 2.0, you don't have to declare your variables. So you just have to call TensorFlow and then you perform addition. So you're just going to use the add just the way it is, A and double D. So and your variables, remember, will remain untrainable. So this means that assuming that for the case of TensorFlow Hub, where we already have our pre-trained models, so that means you will only have to, if you don't want to retrain the model, so that means you have a constant value. So you're going to have that constant input model as you're going to train it. Now let's see this in action. So I'm just going to share my screen almost towards the end so that we can do some little code or just do an hello world program. So let's see. The first thing you're going to do is you're going to define. So this is TensorFlow 1.0. So you're going to say variable, then TF, then like other programming languages, we have actually like predefined keywords. So, and with variables, you have to start with capital V. So you're going to say, I'm declaring a variable. So that's you've already booked a space in your GPU. Then you're going to say, you're going to specify your dimension here. So which type of tensor are you using? So maybe like you have a 2-dimensional tensor or 3x3, or even a cuboid or any other. Then you're going to specify your data type. So this is just the architecture of how a model, how a variable is being, you're going to declare your variable. You're going to place in your variable name, then you're going to call TensorFlow.variable, then you specify your dimension here, then you're going to specify your data type. So for actually not complex, but for intermediate levels and advanced, so you're also going to include your activation function. So maybe like sigmoid or ReLU activation function, or even the gradient descent function. So this it will continue taking in more parameters as it continues. But for simplicity, we're going to just declare this. So we're just going to use this variables. So we are actually using these are one-dimensional tensor with different with the data type of float32, and then we have a second one. So we've just called this one variable _b. This is actually integer, so int 16. Then we have defined a constant. So assuming we want to perform multiplication, then we are going to use this constant already here. Then the data type is float32. And then if you now want to perform your multiplication, then you're going to say, give it a variable name, then call the multiply. So this is a method, and of course, you know that a method has already different code in it. So like multiply, then you're going to pass in your variable one, then your second variable. So these are in reference of the first variable A and the second variable B. Yeah, so so this is especially if you want to specify your shapes. So with TensorFlow, then you're going to call this way. So like TensorFlow, maybe like variable this one, then variable two. Then we are going to specify different shapes. So this is a 2x3 constant. Then we have a 2x2 constant. But remember, this is a one-dimensional tensor. Now let's do some little practicals before we actually end. So let me display now an hello world. So unlike Python, any other languages, like you just use one line, hey, hello world. You just print hello world. So this is almost an hello world. So let's see how we're going to print it because you're going to do anything without sessions. So with this, you're going to say the first thing we have actually like seen about adding variables. And now this is TensorFlow 2.0, unlike TensorFlow 1.0, where you are going to actually like create to define your variables. So in TensorFlow 2.0, 2.0x and above, then you just have to directly call in your variables. So I don't have to define my numbers separately. So what I just have to do is just call TensorFlow, then perform addition. Then the next thing is I have to start sessions. So this was again in TensorFlow 1.0. But in TensorFlow, we are going to see the difference between TensorFlow 1.0 and TensorFlow 2.0. So once you are done with this, then you have to start and close your sessions, just like context managers in, I believe, all other programming languages. So you're going to see shortly how the power of context managers in TensorFlow. So but this is now on TensorFlow 2x. So the first thing you have to do is you have to define your session. So you're going to call tf.session. Then the next thing you're going to do is you're going to print your session. So, but you have to run it. So some typo here, it's not run t, it's just run. Then your variable, the performance you want to do here. Then you actually like call it. So once you have done with everything, then you have to close the session. Now, to the interesting part. So what actually context managers actually do is they help you in doing automated closing. Now, somebody would say, what if I just run my sessions without closing them? So assuming you are using the first part, so that means your computer will have a background task running. So that means you're going to consume resources for your computer. And so this actually like training in Android. So most probably, if you don't stop it, then things will just continue being executed. And then your applications and all your system phone will start consuming a lot of resources. So it's good to close your sessions. So, and then with this, with the context manager, it's very easy. So it combines 3 lines into 2. So you're just going to call with tf.session as. So I just forgot the opening and closing brackets. So the session should be a function with tf.session as says. So says is just a variable, so I can just give it a different name. Then I'm going to print says to run. I'm going to run the name. Then let's see something about TensorBoard. What TensorBoard does is it allows you to visualize your code, to visualize your model. So with this, it's going to give you a whole graph. So like the way we've performed addition, subtraction, and any other, and the other, like you can perform actually different things. Then you can actually like monitor the way your model is performing using graphs, because it's easier for you to visualize the way your model is performing. And so almost to the end. So this is how TensorBoard is. So we have the parts where we have scalars, then we have images, we have graphs, we have distributions, and we have histograms. So what this actually works, how it works is I can perform different epochs. So depending on the number of epochs I'm passing in, then it's going to draw a graph. So I don't have to actually like draw it. So I can code in my VS Code, or I can code in my PyCharm, in my Jupyter notebook, or any other notebook that I'm using for my model. I can code it, then I can just load TensorBoard into maybe like my environment. And I'm just going to show you how you're going to quickly install TensorFlow and Keras in Anaconda. So this is how TensorBoard works. So before we write our first program, you're going to see how we're going to install all this stuff. So the next thing is about the difference about TensorFlow 1 and TensorFlow 2 is the eager execution. So we've talked about the sessions. So it scales 3 lines into 2 lines, of which it once you're using the context one, then you don't have to like worry about you forgetting to close the session. Then there's actually capability of decorators and Keras APIs. So this actually works very well, especially if you are building and deploying your model to the edge. And then we are going to understand more if in case we have more meetups on TensorFlow, what these data pipelines are. So for TensorFlow 1x, you actually had to use placeholders. But now in TensorFlow, you just 2x, you can just directly use your variables without actually like defining them. So you don't need any placeholders. You don't need any variables. Especially when it comes again to model training, you just have to import your model once, and then you don't have to keep recalling the session. On TensorFlow 1x, a lot of libraries were actually like done away with, which actually like made it easy for training and serving models on especially the TPU, TPU.js. So with simplicity, so after all that, after you've already like have your data set and everything, so this is how everything is going to work within your model. So the first thing that happens is you're going to perform data preprocessor. So you're going to actually like architecture your data, the number of columns, the way you're going to arrange your data. Then we have TensorFlow tf.keras. So tf.keras is going to perform the mathematical computations and any other thing that you need. Then you have the CPU strategy. So it depends if you're using a CPU, GPU, or CPU. So once you've already finished, so during the training, this is where you CPU, GPU are in use. So that's why once you have done completely training the model, then you go into the saved model stage. So once you are here, this is where now you determine where you want to deploy your model. So assuming I was doing a mask detection model in TensorFlow for COVID-19. So I'm going to, once I've already trained and I'm in the saved state model, then I can directly go to now like the deployment process where I can deploy it using TensorFlow serving. So thinking of maybe like using cloud to perform my deployment. Then if you're using Android, if you're an Android person, so there are a lot of Android devices, like the way Tambua are using Tambua Health for detection. So they have an Android app, so which will now like give the doctor the visualization using graphs in Tensors and presenting it on the phone. You can actually use TensorFlow Lite. So TensorFlow Lite is another whole thing in Android, so which is another differentiation. TensorFlow JS again, it is another whole thing, web meetup on its own. So once you already have your model trained, then you can determine like, do I really want it as a mobile platform or as a web platform? Then it's also binded with Go. So if I used Go, Java, or C, then for IoT and embedded systems, so you're going to deploy your model into, because they use C and C++ programming. So for Java, that's already covered. Go again. Then we have C#, then Rust, and then for gaming deployments and any other languages. So this actually allows TensorFlow and makes TensorFlow one of the biggest libraries in machine learning. Yeah, so that is it. So we're going to perform our last, we're going to do a few code sessions. So mostly around 10, not 10 minutes. I feel like let's just do 5 minutes so that we can have actually some questions. So I'm going to stop sharing so that I can share my screen for Anaconda. So I'm going to share my entire screen so that we can start code a few code. Yeah, so I'm going to just start my Anaconda. So I'm just going to say Jupyter. So in my environment, I have two different ways. So I'm just going to start the TensorFlow one. But before I start TensorFlow, allow me to start Anaconda so that I can show you the way you can install TensorFlow so that you can directly stop going to like the internet to like start reinstalling and installing TensorFlow using maybe, let's say, if you're using the internet to like code. So I'm going to say maybe like Jupyter Notebook. So with the Jupyter Notebook, it enables you to run your models online if you don't want to install your the device, the environment. So once it's started, then this is your environment. So if you want to install TensorFlow offline, so the first thing you're going to do is you're going into your environment. So if you click on the far left, we have environment. So for me, I already have TensorFlow here. So once I have TensorFlow here, so you're just going to create a new environment. So for your case, when you're starting Anaconda, then you won't see this environment here called a TensorFlow. So what you do is you're going to create an environment. So you just click on create, and then you're going to give your environment a name. So maybe like, let's say Keras. But of course, you can just directly install a Keras into a TensorFlow. So there's no need. So you're just going to create a TensorFlow. So once you have these, and then you can directly go to create. Now, once you're already done with that, then you're going to uncheck this one. So you go to the place where it's we have the places for not installed and installed. So you're going to select the part of not installed. So once you have this node installed, you are going to search for TensorFlow. So once you search for TensorFlow, it's going to bring you TensorFlow. So then from that, I want you to select the environment where it's written TensorFlow for machine learning. So of course, I already have it installed. Then Keras will be here at the top, just next to Keras GPU. So I'm going to switch back to my installed. So if you look at this, then the Keras that I want you to install is a deep learning library for Theano and TensorFlow. That is the Keras one. Then for TensorFlow, I would want you to install with a description called TensorFlow is a machine learning library. So that will install everything with TensorFlow. So once you are done with that, then you can now directly start your Jupyter. I'm going to start my Jupyter environment. So once you start your Jupyter, then you're going to have two environments. So we have at the base and TensorFlow. So I'm just going to start my TensorFlow. So once I start my TensorFlow, so the terminal will open, then it's going to direct me to where I want to start, maybe like writing code for TensorFlow. Now, so once I have my environment up and running, so the next thing I can do is I'm going to head directly to my new. So once I have new, then I can select Python 3. Then it's going to bring in an environment. Try to zoom this one. Yeah, so once we have this, of course, because we have already installed TensorFlow in Anaconda, then we won't have to say maybe like pip install TensorFlow. Unless now you're using this other version, so that's you're using the Jupyter trial version. So the Jupyter online, so you'd have to scroll, then you can maybe like select try in browser. So then we're going to select Jupyter. So if you don't want to install TensorFlow, but of course I'm not sure why you won't want to install yet you want to start learning and building models in TensorFlow. So once you have that, then you can directly, so the binder usually takes a little bit time to like start the editor, depending on your internet speed. So mine is a little bit slow. So once it's online, so let me see. Yep, the binder is still running. So for this case, I'm launching these two environments so that we can see the difference. Actually, like the benefit of having it on localhost, so that's your Anaconda, than having it on binder. So once you have this, then you can start directly. You can launch Python 3. Then you can now perform like, of course, I cannot directly say import TensorFlow as TF, and if I run this, of course, it's going to bring me an error. Let me see if I can increase this. Cool. So if I now run this, then it's going to throw in an error. It says I don't have TensorFlow because I'm running it online. So the first thing I have to do is I have to install. So to install TensorFlow, you have to say pip install TensorFlow. Then you're going to run it. So once you run it, then it's going to quickly install, depending again on the internet speed. Then you can now like say import TensorFlow as TF. So if you now run this, then you expect no error. So this is, of course, we have not specified the version. So of course, it's going to install the latest. So that's 2+. So if you're going to perform additions and place all the variables, then it's going to throw as an error. So to do a practical one, so let's try to make something interesting. So let's say now we want to print hello world in TensorFlow. So I'm going to do it. So let's do it the old school way. So that's TensorFlow 1.0. So to do that, you're going to first maybe like declare your variables. Okay, cool. So once you declare, so you're going to say TF. Well, let's give it a variable name first. Let's say hello. Then you're going to say tf.constant. So let's just use constant for now. Then you're going to have the opening and closing brackets. So once we have the tf.constant, then we can now pass in a string here. So we can say maybe like something like hello world TensorFlow. Now to run this, so I'm not going to do a guidance on how to use code labs. So you're going to just learn it. So just make sure you have there's a icon here for playing music. So that's what you're going to play around when running your model. So the first thing is you have to declare your variables. Then the next thing is you have to start your sessions. So I'm going to say my sessions is equal to, so I'm just giving it a variable name of sets, tf.session. So remember again, once you're declaring your session here, so you have to place the opening and closing brackets. So this will show you, this will tell actually the notebook that this is a TensorFlow function. So once I run this, so make sure that you run each and every block. So then I'm going to say, so assuming I want to print this, so then I'm going to print this session. So remember, you have to call the session. So let's say display the output. So you're going to say print sales.run. So you must make sure that your session is up and running. And remember, don't forget, once you are done, then you have to close your session. So to do that, you're going to call sales.close. And remember, again, it's a function, so you have to have your opening and closing brackets. So we can now run this and see what's going to happen. So we forgot something. So we forgot to place what we want to run or what we want to display. What we want to display is this variable here. And all this statement is being held in a variable called hello. But because I've clicked on this, so remember that I have to run it again. So once you click on a box, you have to rerun it to make sure that it's up and running. So once I run that, okay, so we have a session missing one feature. So let's do this. Place our string inside here. So it's hello. Now, on that, then we now see that we have hello world TensorFlow. So this is how you perform your TensorFlow. But because we have TensorFlow 2.0 installed, so directly we don't have to perform actually like a variable declaration. So let's say we want to use a context manager in displaying this variable. So let's change something here. Then let's say hello world TensorFlow with our context manager. So you can see like how quick is it. So once you click on this, then maybe like you can just run. Because we won't have to rerun these cells again because we don't want to use this. So we're going to use a context manager. So we're going to say with the tf.session, then you call as cells. Then we can directly print now, print cells.run. So once you have the run, then we're going to pass in hello inside here. Then we can now see like how many lines we are saving with context managers as compared to this old way. So once we run that, we now have hello world TensorFlow with context. So that's how you run your variable. You actually use context managers. So I'm really seeing time is really going fast. So let's perform maybe like a multiplication or addition. So but now let's use the other way. We're going to use Anaconda one. So once we have this, so we can directly, so we don't have to install now TensorFlow. So let me view this one in presentation mode. Okay, but I hope it's visible now. Yeah. So I'm just going to directly import TensorFlow as TF. So once I run this, I'm not getting an error because I'd already installed TensorFlow in my Anaconda. So we can now perform addition. So let's now do is the TensorFlow 2.0 way. So let's this one addition. Maybe like add a b. Then we're going to say tf.add. Then we're going to pass in maybe like numbers. So maybe like 5 or. Then once we are done with that, we can run that cell. So then we can directly print this. So we can print add a b. So once we run that, it prints as the type of tensor. So it prints out that this is a data type of integer 32 with a shape. Then the sum is of 8. So this is what TensorFlow actually like. TensorFlow 2.0 makes it easier for us. Because of time, I'm just going to display the tensor board. Then I don't think we need to run any other more code. So let's perform. If you want to use strictly TensorFlow 1.0, then you're going instead of importing the old TensorFlow, you're going to say TensorFlow.compat. Then you're going to put a period here, period there. Then you're going to specify the version. So maybe like I'm using TensorFlow version 1. Okay, yeah. So if you run that, then it's working fine. Now, to make sure that you don't have errors, you don't have confliction with TensorFlow 2.0, then you're going to disable the behavior of TensorFlow version 2. So what you're going to do is you're going to say tf.disable, then an underscore version 2 behavior spelling. Oh, I hope that is the right spelling. So if I run that, then everything. Okay, my spelling. Behavior. Interesting. My people, how do you spell behavior now? Tabi, how do you spell behavior? I hope this way.
Yes.
Okay, cool. anyway, you have to specify like the behavior you are trying to eliminate the behavior here. So actually, it's like you are trying to disable the way TensorFlow 2.0 wants its variables. I won't add it right, not the spelling of behavior. Anyway, that is it. So Teams doesn't know a lot of English, but that's how you do it. And then it's going to work the way you're going to specify and work with TensorFlow 1.0. But it's actually better off when you work with TensorFlow 2.0. So I'm going to just TensorFlow. Let's go with TensorFlow Hub. So what a TensorFlow Hub is, it provides you with training models. So you don't have to already pre-trained models. You don't have to go on like looking for new models unless it's a new field where you want to retrain, start training all your models. So this is how you're going to perform everything. So if you want to like take more on TensorFlow because of time, then you can check on tensorflow.org. Then there are some awesome books for TensorFlow written by, how do we call this community? So I've forgotten the name of the community, but hopefully I'll remember before the end of the session. So this is how you actually like run into TensorFlow for the first time and you get to interact more with TensorFlow. So because we have less than 6 minutes, so I'm going to cut my presentation short and maybe like welcome any questions concerning the use of TensorFlow and anyone who wants to like get started with TensorFlow or anything like that. So thank you so much. So that was really very, TensorFlow is huge for a 1 hour session. Yeah. So, and I hope you got something. Yeah. Thanks.
Thank you so much, James. Okay. I like the part where you said,
yeah, English.
Yeah, thank you so much for taking time, to take us through TensorFlow. I think there was one question by Sharon. She wanted to know if, as a beginner, you should start with TensorFlow 1.0 before 2.0. You can directly go to 2.0 without having experience with 1.0.
Yeah, so I started TensorFlow when it was still TensorFlow 1.0. So it's easier for me to like see the transition in. But as for somebody who's beginning in TensorFlow, there's no need to go to TensorFlow 1.1 because if you're going to learn about TensorFlow 2.0, then it's going to become like a little bit easier for you to base back to TensorFlow 1.0. So there's always documentation at TensorFlow. So if you have any, like, if you need any reference, so tensorflow.org blog and websites are actually like they show the difference between TensorFlow 2.0 and TensorFlow 1.0. So that's actually like especially what makes it interesting about TensorFlow. But it's really very, very easy and very nice to directly go into TensorFlow. It's just like somebody saying, do I study in Android with Kotlin or Java? No need for Java. So for TensorFlow, no need for TensorFlow 1.0. Just go directly to TensorFlow 2.0. Yeah.
Oh, okay. That's nice. I'm not really sure if there are any more questions, but as we wait for people to ask, maybe you could give us, what do they call them? This last last part that Mika says parting shot, like you're new to this TensorFlow thing, you want to start out, maybe resources that I can actually get into, maybe of course I know the recording of this session will be there, but something I can do on my own, yeah, that will guide me like step to step. If you have such resources we can share with people.
Yeah. So concerning TensorFlow, this is actually like one of the most in-demand actually technologies. So look at the way Tambua Health. I actually like envy like Tambua Health. They're really a nice organization and they're really killing it with TensorFlow. Especially being proud so much being a Kenyan company and the Kenyan organization. So hopefully one day I'll work there. So for what actually makes it interesting for me is the way Tambo Health was solving the problem. So this was a problem that was actually, the problem was not a new problem, but they were improvising a problem. So they were trying to make it easy for doctors and actually like increasing predictions. So nowadays we are actually like studying online, so you won't trust the doctor so much like how they studied. But with this machine learning way, so it's gonna be easier for different farms to like get an output. So take for example the cases of quantum computing. Everything is powered by machines, and the machines are being trained in machine learning. So one thing about TensorFlow is it you can deploy it actually, especially with TensorFlow Lite, TensorFlow JS, and these other lightweight libraries for TensorFlow. So you can actually like deploy them actually in these models. So, and it's very, very easy to learn TensorFlow. If you know Python, you know TensorFlow. So the one thing that I would just want to tell a beginner or somebody who wants to get started with TensorFlow is get to master Python. And then for the resources, I want you
Are
to
you
check.
breaking or is it my network?
No, your network. No, but but I hope I'm clear. Anyway, we are in the last part. So what I was saying to say is for somebody who wants to get started with TensorFlow, Lawrence Moroni is doing some amazing beginner tutorial based on TensorFlow. So check out TensorFlow from Lawrence Moroni. Is also an author. So you can check on his books. So he's written a lot. So if you just search on YouTube Lawrence Moroni or TensorFlow, then you get to a whole bunch of resources. Then another one is Code with Team. So you find Code with Team with a nice tutorial there for TensorFlow. And then there is the TensorFlow GitHub repository. So once you're up and running, then one more is DataCamp. So DataCamp has it's almost free because it's 500 shillings. I hope so. It's still 500. So I paid 500 to learn TensorFlow and DataCamp, and it's really very nice, step by step. So you can get to start from actually that point. Yeah. And the field is really, really still very demanding. Welcome to the field of TensorFlow. Tabby, back to you.
Sorry, I was trying to get no, I was trying to get the link to Lawrence Moroni's YouTube. There.
Oh yeah.
I think that's it. But you can actually go and Google. I was trying to Google and also come back here. But yeah, thank you. Yeah. So I'd like you to talk about. I don't know if you've interacted with TensorFlow.js. I don't know if you are a JavaScript person like some of us.
I just launched into web like 2 months ago because of TensorFlow. So yeah, but I'm not doing websites. I'm just doing TensorFlow.js. So the thing about TensorFlow.js is it's easier to learn than doing Android TensorFlow Lite. So because TensorFlow Lite you'll have to understand and remember a whole bunch of Android Studio problems is another hectic stuff. So but with TensorFlow.js you can directly build a model and have a preview. It's more light on actually like the web browser than actually like running it on Android. So because on Android, remember you have to have a phone. Android Studio, of course, is another heavy stuff. Then you have to understand Java or Kotlin. Then you have to understand all those states in Android. So somebody who is new and doesn't want to really code much, code the TensorFlow.js way. But if you are a master, welcome to TensorFlow Lite suite. Yeah, but it's very fun.
So I think Sharon has talked about you can reach out to because she says she'll get started with TensorFlow.js. So Sharon, go and look for Teams on Twitter. Then you can be disturbing him from there. Yes, I don't think we have any more questions, but if you have any questions, you can always reach out to Teams. His Twitter handle is Teams. Where is your slide? At Teams _Owen, right?
Yeah.
You just the ALC boy. This is an ALC. Yeah, Teams Owen. Utamwona tu hapo na laptop yake. Yeah, so feel free to reach out to him and ask him questions. Thank you so much, teams, for taking time, we hope that maybe you'll come over again and take us through Tensorflow again because you said it's wide. Yeah,
Yeah.
we are looking forward to learning new things about Tensorflow. Yeah, so if you allow me, I think we have come to the end of our session. Yeah, I've seen some pretty nice comments from your fans. They enjoyed your presentation, which is nice. So yeah, so that's it from us. That's it from Chico, Nairobi, and Tim's Owen. We'll get back to you guys very soon with yet another event. Yeah, they say keep it locked. Have yourself a wonderful night.
Goodbye.
Yeah.